Today we're going to get a little introduction to exponential functions. Make sure you got this handout so you don't have to copy it by hand. But before we talk about exponential functions, let's review linear and quadratic functions. So first, linear. One way to write a linear function is y equals mx plus b. Now that's called slope-intercept form. We also have point slope and standard form. But this is my fave. A little reminder, this m right here is the slope, and b is the y-intercept. So you'll know it's linear because we just have that x, no exponent on it. Alright, for a chart, you can tell it's linear by looking at the first set of differences. So for example, looking at your y's, going from 1 to 3, we add 2. 3 to 5, add 2. 5 to 7, add 2. Or over here, to go from 1 to 0, you subtract 1. 0 to negative 1, subtract 1. Negative 1 to negative 2, subtract 1. So we call this the first difference, or the first set of differences, and it's constant. Constant meaning we have the same number each time. Okay, let's look at a graph. So a graph of a linear function can be increasing like this, meaning going from left to right, it goes up. And in which case our domain, you notice it never stops going left and right, so our domain is all real numbers. And the range, it never stops going up and down, so what do you think the range is? Yeah, it's all real numbers again. Okay, this could also be decreasing. So going from left to right could go down. And guess what the domain is? Yeah, all real numbers. And range, same thing, all real numbers. And a reminder, I hope you already know this. This is called a line. Again, I really hope you know that. Okay, let's do a review of quadratics. So quadratic functions can be written in standard form, which is f of x, or y, equals ax squared plus bx plus c. And this c right here is the y-intercept. And a tells us the shape of, or whether our quadratic opens up or down. So this a, if a is positive, so if we have a positive a, you're going to have it opening up like that. If a is negative, it'll open down. So that means positive a, negative a. Alright, and the way you can tell that it's quadratic is look at the exponent. If your greatest term, your greatest degree is x squared, no x to the third, no x to the fourth, it's quadratic. Alright, for a chart, again, we got to look at our differences. So to go from 0 to 1, we added 1. To go from 1 to 4, you add 3. To go from 4 to 9, you add 5. Notice our first set of differences is not constant, so it's not linear. Let's look at our second set of differences. To go from 1 to 3, we added 2. To go from 3 to 5, we added 2. So the second set of differences is constant. All right, let's look at the graph. So graph, we could have, like we said earlier, a could be positive, in which case you'd have a graph like this. Okay, so let's look at the domain. So going left to right, does it ever stop going left and right? No. So the domain is all real numbers. The range, since it opens up, we're going to have y's greater than something. Well, this one stops right at y equals 0, so y has to be greater than or equal to 0. All right, what about if a is negative? So if a is negative, you'd have something like this. Okay, for domain, look at left and right. It never stops going left or right, so the domain is all real numbers. Range, it starts at 0 and goes down. So y could be equal to 0 or it can be less. So y is less than or equal to 0. So again, all of that should have been reviewed. I really hope it was. The next part is new, so pay close attention. Okay, exponential functions are written as f of x, and remember, f of x is really the same as y. F of x equals a times b to the x power. So that's why it's called exponential, is because your x is the exponent. Now this letter a right here is the y-intercept. So that number right there tells us where the graph crosses the y-axis. B is called the common ratio. And it'll make more sense why it's called that when we look at our chart. So B could be greater than 1. And if B is greater than 1, we're going to say this is exponential growth. Which makes sense because, as your age goes up, it's greater than 1, you're growing. Okay, if B is between 0 and 1, so if it's a fraction between 0 and 1, we call that exponential decay. And in biology, I don't know if you've talked about it yet in biology. If you haven't, you will at some point. In biology, you use this a lot to talk about the growth or decay of a population or of radioactive samples if you're in chemistry and whatnot. So here's our exponential function. Let's look at the chart. So for a chart, you're going to look at what you multiply by. So to go from 1 to 3, we multiplied by 3. To go from 3 to 9, again, we multiplied by 3. To go from 9 to 27, we multiplied by 3. This is B, which again is called our common ratio. All right, so notice for this chart, B equals 3. Well, 3 is greater than 1, so do you think this is growth or decay? This is definitely growth. This is exponential growth. Okay, let's look at this chart. Here's another example. To go from 20 to 10, we multiplied by 1/2. To go from 10 to 5, we multiplied by 1/2. And to go from 5 to 2.5, notice that's 0.5, we multiplied by 1/2. You got it. So again, this 1/2 is our B, which again, guess what that's called? Common ratio. And since B equals 1/2, that number, 1/2, is between 0 and 1. So this would be called exponential decay. All right, last thing we need to talk about is the graph. Okay, our graph can look two different ways. So if we have growth, let's look at our growth graph. So this is if B is greater than 1. It's going to look something like this. That's growth. Something that's really, really super important. Notice it gets really close to the x-axis. Okay, so it gets close to what really is y equals 0. The x-axis is where y equals 0. But it never quite touches. That's important. So we'll get to that in just a moment. So let's look at domain. So going left and right, does it ever stop going left and right? No. So domain is all real numbers. The range, I see if it's bigger than 0, y can be bigger than 0, it cannot be less than 0. So y is greater than 0. But here's the thing, that red line, our graph never touches that red line. So it cannot be equal to 0. Y can never be equal to 0 on this. And you'll find out in Algebra 2 that we can move this graph up and down and the range can change. But for us, we're always going to have this line right here. It's never going to touch y equals 0. Okay, what about decay? Decay would look like this. And once again, we have this line where it does not touch, it never touches y equals 0. And this line is called the asymptote. Yes, funny word, I know. That's called the asymptote. Okay? And it never touches. So for us, the asymptote is always going to be at y equals 0. So for us, it's always at y equals 0. In Algebra 2, it can change, but for us, it's just going to be right there. So what do you think the domain of this is? Well, going left and right never stops. So it's all real numbers. What about the range? Again, we get really close to 0, we never touch it, and we can be bigger than that. So your range is y is greater than 0. So the exact same domain and range. All right, you have some practice. Get to that. Let me know where I lost you, where you have questions. I am here to help.